So you have seen this before. This is just what we talked about 2 classes ago. This will be a number. This will be a number. This will be a number. And that will be a number. So A, B, C, and D will just be numbers. They might be 0, but they're still numbers. So in terms of transformations, what do we call a multiplication outside the brackets way in front? In terms of sinusoidal functions, we call that the amplitude, which we talked about that word yesterday a little bit. And if you've done physics, amplitude is the height of the wave, and so that's why it affects the y coordinate, and that's why it's vertical. It's how high your wave is or how low.
If, say, the wave on a graph is like, it goes up and then down and then up again, would the amplitude be the highest point?
Yeah, it doesn't matter. We go from center line to the top or center line to the bottom. So you'll see an example once we get there. So it's either or, which will make more sense in a minute. What do we call a multiplication inside the brackets? Horizontal stretch or compression. In terms of vocabulary for sinusoidal functions, what did we talk about yesterday? Amplitude and period. And I'm going to put a star beside that and I'll come back to it. In physics, they sometimes call this frequency. So even if you haven't done physics, you've probably heard that word in terms of sound. And this is a horizontal movement. So as things get stretched out, the sound gets lower. As they get squished in, it gets higher. So that's how you get different frequencies in sound. It's the period or how many repetitions there are. C in terms of transformation, so inside the brackets and an addition or subtraction. Horizontal translation. Okay, so again, that's a side-to-side movement. And in terms of sinusoidal equation, it's called the phase shift. Fancy schmancy. Phase shift. And that actually comes from phases of the moon, which is a sinusoidal equation. D, in terms of transformation, so outside the brackets, addition or subtraction is perfect, and that's an up and down movement. In terms of sinusoidal equation, this is called the center line. Sometimes called the vertical shift, which is the same as translation. So we're going to do a bunch of things today with this A, B, C, and D. The first, I'm going to give you an equation, and we're going to list them. What is A, B, C, and D? Later on, I'm going to give you the A, B, C, and D. You're going to give me the equation, so going backwards. And then the last thing we're going to do today is given a graph, we're going to get the equation. Okay, so lots of stuff today with sinusoidal equations. So for the trigonometric functions below, we're going to identify the amplitude, period, phase shift, and center line. Because mathematicians don't like words, they scare us. Amplitude is A, period is B, and I'm putting a star because I'm going to come back to that one. Phase shift is C, and center line is D. Because I forgot it. I be not your English teacher. So A, B, C, and D. So A is called the amplitude. It's the same as the vertical stretch or compression. So where do we find it in the equation? Where do we find the A? So look up if you're not sure. Where do we find the A? Out in front, so the amplitude of this one is 3. The B value is tucked in between the sign and the X, and sometimes they're brackets, sometimes they're not. We get lazy with that. Is there a number between sign and the X? Well, there is. We just don't see it. So we know that the B value is 1. C will also be inside the brackets, and it's a subtraction or an addition. Do we have an addition or subtraction inside brackets? So that means that the C value is 0. Or we say the phase shift is 0. And D is at the end of the equation, the addition subtraction, so our center line is 4. So that's all we're doing with this one is we're just practicing finding the amplitude, the period, the phase shift, and the center line. Now I want to go back to B. B is not quite the period, it's kind of the period. The actual formula is B is 2 pi divided by the period, because we know 1 revolution of the circle is 2 pi. And if I rearrange this equation, I can put P onto the left, and I can say it's 2 pi divided by B. So it just depends if the question is asking for the period or the question is asking for B. So although the B is 1, the question is actually asked for the period. So we're just using this little formula here. The period is 2 pi divided by B. And in this case, B is 1. I guess I didn't need to do an imaginary. It is 1. And so B is 1, but the period ends up being 2 pi. So there's a relationship with B and P, but they're not exactly the same. It's 2 pi divided by B equals P, or 2 pi divided by P equals B.
Is the period supposed to be T?
Why T?
Isn't that what it is?
Oh, but physics people are crazy. Physics people typically do because it's over time, but we don't do that. Stupid physics people. Okay, so the other 3 you can pick right from the equation. B, you just have to do a little bit of work because they're not quite equal to each other. Okay, same thing here, amplitude, period, phase shift, and center line. Amplitude is the number in front, and amplitude is a distance, so we never count the negative. So you'll often see an absolute value around the amplitude. That just means whatever the value is in front, change it positive, because it's a distance. So although the value is -2, we say that the amplitude is +2, because it's a distance. I'm going to come back to P because it's the scariest one. I'm going to go to C. C is adding or subtracting inside the brackets. Do we even have brackets? So what's our C value? 0. D is adding or subtracting outside the brackets. Do we have anything adding or subtracting? So our D value is 0. Going back to P, I'm going to take 2 pi divided by the B value. The B value is always tucked between the sine or cos and the x, so in this case it's 1/2. How do I divide fractions? Okay, so I'm going to take that 1/2 and flip it. And so the period is 4 pi.
What's A again?
A is the amplitude, the height of the graph. It's a distance, so it's always positive. Because all the negative means is that we flipped it, but that's not going to change the amplitude. Okay, so same thing, amplitude, period, phase shift, center line. Where do we find A? In front, beginning of the equation. What's the amplitude of this graph? 1. So that means it goes 1 unit up and 1 unit down. P is 2 pi divided by the period, or period is 2 pi divided by B. B is always tucked in between the sign and the variable. Do we have a B value? 2. So 2 pi divided by 2? Pi. And the reason that is because that's a horizontal compression and we've squished it in half the distance. So if I take something that's the distance of 2 pi and I squish it in halfway, what's the new distance? Pi, and that's why it ends up being. Same thing up here. We know this would have been a horizontal stretch, twice the distance. So if I stretch something out and it was 2 pi and I yank it twice the distance, where is it going to be now? 4 pi. That's why the B and P value are related. C is the phase shift inside brackets. Is there an addition or a subtraction? Yes, and remember when it's horizontal it changes. So although this says 3, this is going to end up going -3 or 3 to the left if you'd rather think about it that way. D is the number at the end, so the center line. Is there any number outside brackets that we're adding? 0. Okay, so that's the first skill you need to be able to do today. It's given an equation, identify those 4 things. Now we're going to do exactly the same but backwards. I've given you some properties. We're going to write a sinusoidal equation. So just so we don't have to flip back, I'm just going to throw it back on the top. Sinusoidal equations start with A, then sine or cos, B, x minus c, plus d. You'll figure out when we get down to example 3. At this point, it doesn't matter. Okay, amplitude of 3, is that an A, B, C, or D value? So I know that I'm going to, in a second, have an A equal to 3. Period, does that affect A, B, C, or D? B. Now, it's not equal to B, it affects B. So if I'm given the period, how do I find the B value? 2 pi divided by the period. And the period they've given us is 2. So 2 pi divided by 2 is pi. So again, P and B are not exactly the same, they're just related to each other. Phase shift of 2, which of these letters in here is the phase shift? C. Does it mention a center line? Does it mention a vertical translation? So we don't need to write down D, but if you want to think of it in terms of numbers, what is D? It's 0, right? We don't have it. That work is optional. If you don't like listing it out like that, don't. What you have to give is the answer I'm going to give now, which is the equation. We have to start with y equals. You can't just start with A because it's an equation, not an expression. And now we're just going to put everything in. A is 3. Then we follow with the trig function. B is pi. Open the bracket. If I'm going 2, which is positive, inside the brackets it becomes negative. And then just for this example, I'm going to put the plus 0 just so you see that we talked about it, but we know we don't need to have plus 0 there. There's the equation that has an amplitude of 3, a period of 2, and a phase shift of 2. Okay, amplitude of 4. What letter is going to be 4? A. Period of pi doesn't mean that B is pi, just means there's a relationship. 2 pi divided by pi, the B value is going to be 2. Do I have a C value? Nope. Do I have a D value? And D is negative 2. Again, you don't have to list them out if that's not your thing because it's very left brain. Great, you just need to give the equation. We have to start with y equals. You can't just start in with A because it's an equation. A is going to be followed by your trig function, sine or cos, doesn't matter, followed by, which is 2. Do I need to open a bracket? Why not? Because there is no C, so I can just follow right with the x. And at the end, minus 2. There's the trig equation that has an amplitude of 4, a period of pi, and a vertical shift of 2. Find a friend, try letter C. Yes, I'm suggesting you talk to each other. It's crazy, I know.
Oh, is it 1?
Which one's the hardest one? Period is always going to be the hardest one because it's not just a direct substitution. So we need to do 2 pi divided by the period. Period we're given is 2/3. How do we divide fractions? So what am I going to multiply by? Okay, top times top. Oh, ahead of me. Can we reduce? Y equals. Confirm? Why is there no A value? Yeah, there is an A value, it's 1. Is there any C value? So we don't need brackets. There you go. Second thing you need to be able to do is, given the characteristics, give me a sinusoidal equation. So backwards to what the first example was. Last thing we're going to do, and we're going to practice with a few examples, is here's the graph, you tell me what the equation was. So everything we've done in transformations, backwards. Usually I'm giving you the function and saying draw it. This time it's been drawn. You tell me what was drawn. Okay, method box for the wordy people. If you're not a wordy person, just wait and we'll do the example in a second. The first thing you have to do is you have to decide what the base graph is. Because these are periodic and they're sinusoidal, we talked Monday, Tuesday, whatever day it was, about how sine and cos are really the same graph. One is just pushed over a little bit. So with this graph, it totally depends where you decide to cut it. And I don't want you to draw on your graph, so just watch what I'm going to do. Let's say that I only show you this part of the graph. Which graph starts at the top, goes to a min, and goes back up to a max? That's a cos graph. Well, what if I was like, no, I want to show you this part of the graph. So I want to show you a graph that starts in the middle, goes up, goes down, and comes back to the middle. That's a sine graph. Have I changed the graph? Did I redraw it? Did I move it? No, I just showed you a different part of it. What if I was like, ooh, these kids are really smart. I'm going to show them this part of the graph instead. So what graph starts at the bottom, goes all the way to the top, and goes back down to the bottom? Cosecant has asymptotes. Okay, but what graph does this look like? Well, it kind of looks like cos, except it's flipped. So what kind of graph flips? No, cotangent has asymptotes. Secant has asymptotes. Inverse goes along the y-axis. This is just a vertical reflection. This is just negative cos. It's just a vertical reflection. What if I was like, ooh, let's show them this side way over here, and let's only show them to there? So what graph goes down and then up and then goes back to the middle? That's just a negative sine graph. You have 4 options for your base graph. You can use positive sine, positive cos, negative sine, negative cos. It is totally up to you. I didn't change the graph. I just showed you different sections of it. I'm going to explain that again when we get back to the example. So you have 4 choices for base graph, and it is completely up to you. You could choose to do a sine graph. Sine starts at a max, goes down to the min, goes back up to a max. You could choose to do a sine graph. Sine graph starts at the center, goes up, goes down, and returns to the center. You could choose to do a negative cos graph, which starts at the bottom, goes all the way up, and come back down to the bottom. Or you could choose to do a negative sine graph that starts at the center line, goes down, goes up, and returns to the center line. It is completely up to you. They're all the right answer. The problem is, if you don't pick the exact one that the book does, your answer is going to be different than the back. And I'm going to show you when we do the example how to compare your answer to the book. So this is a y equals cos graph. So y equals cos theta or cos x. The second is a sine graph, so y equals sine theta. The third is just a vertical reflection, so it's y equals negative cos theta. And the last one is a vertical reflection, so y equals negative sine theta. And I'm going to talk a lot about starting points and end points. You need to pick that first. And what that means is that the starting point is at the top for cos, and the end point is also at the top. So we say it goes from top to top. With sine, the starting point is on the center line, or the y-axis in this case, and it goes back to the y-axis. So that's called the starting point and the end point. X-axis, yes, thank you. Negative cos starts at the bottom and ends at the bottom. And negative sine starts at the center line and goes down, then goes up and returns to the center line. It is your choice which of those you choose. And as we go through examples, I'll tell you which is the better choice, because sometimes some of them are easier. But just because you choose a different base graph doesn't mean your answer is wrong. First thing you need to do is calculate the center line. How do we calculate the center line? We take whatever the max value is. we add it to the min value, and then we divide by 2. All I'm doing is averaging. I'm going halfway between the max and min. Then we need to find that A, B, C, D in order to put them into the equation. I always start with D because it's the easiest. D is the center line, so once you have the center line, you've done D. I do A next because it's the second easiest. What's the definition of A? And so that's the distance from the center line to a max or the center line to a min. Doesn't matter, it'll all be the same distance because the graphs are symmetric. So it's the number of units from the center line to a max or the center line to a min. Then I go to B, which is the nastiest of all of them, and it's always 2 pi divided by the period. And the period is the length of the graph, or 1 revolution of the circle. So that's the distance from starting point to end point. That's why it's important to mark the points at the beginning, because the distance between them will be what you divide 2 pi by. And again, for the non-wordy people, wait till we do the example. This is going to make more sense. C is the phase shift, or the horizontal translation. So that is the distance from the y-axis to your starting point, because that will tell you how much you've shifted it over. So distance from the y-axis to your starting point. And then we just substitute those into the equation, and we're done. Whew. Seems like lots of steps. We're going to do a bunch of examples, and you'll see by tomorrow this will become really easy because it's the same steps every single time. Okay, so let's go to example number 3. First, all the instructions ask for 2 different sinusoidal equations. How many different ones could we write? Could we write more than 4? Sure, because these go on forever and ever and ever because it's periodic. So there are a million bajillion infinite number of equations we could write. First thing I like to do is draw the center line because it's going to help you to get your starting point. So I actually start with the center line before I do the base graph. How do we calculate the center line? Peek at the method box, we wrote it down, that's why it's there. We take the max plus the min, divide by 2. And you don't need to show the work, I'm just going to show it so you understand what we're doing. Max is the highest point on the graph. What's its y value? -2. The min is the lowest point on the graph. What's its y value? And then I'm going to divide by 2 because I want halfway. So -2 plus -4 is -6. -6 divided by 2? -3. And you'll know when you go to draw it if you're off, because then it won't look like it's right in the middle. Nope, that's totally up to you. If you can just see it off the graph, great. So let's do a sine graph first. We've got tons of choices here. Sine graphs start at the center line and end at the center line. If you want a positive sine graph, they go up and then down. If you want a negative sine graph, they go down then up. That's why I like to draw the center line first, because sometimes it's easier to see where those endpoints are going to be. So here's one option. I can cut it there and I can cut it here. So there's from center line back to the center line. Would that be a positive sine graph or a negative sine graph? Why positive? Because it goes up before you go down. So I always think of a roller coaster, and roller coasters typically go up first, then down. If you go down first, what's going to happen at the bottom of that roller coaster? You're not going to have the momentum to go back up. That's not a positive roller coaster experience. That's a negative roller coaster experience, because that's lame. You go down and sit there. So a positive roller coaster experience is going up first, then down, except for me, because I puke on roller coasters. What if I chose to cut it here? There's center line to center line. Would that be a negative sine graph or a positive sine graph? Negative. You're going down and then your roller coaster ride is really, really negative. Your choice. It is completely up to you. Your answer will still be correct just because you choose different endpoints. I'm going to go for the obvious one, and I'm going to start here with my endpoint or starting point, and I'm going to come back here. And for the visual people, I'm going to highlight just that section of the graph. So because I've chosen that, we are doing a positive sine function. In a second, I'll do the cos one and show you what it looks like. So step number one, I actually do center line first because I find it easier to get the endpoint. So center line is somewhere in there. Second step is you're marking endpoints and you're choosing your base graph. We have chosen to do a positive sign. Now we need the A, B, C, and D. I go to D first because it is the center line. Whatever you calculated in step one is exactly the D value because that's how much we've dropped it down. That's our vertical translation. Next, I go to amplitude because it's related to the center line. Amplitude is the distance from the center line to a max or the distance from the center line to a min. It doesn't matter because the graph is symmetric. So how many units is there between our center line to our max or our center line to our min? 1. Well, why isn't it negative if we're underneath the? Because it's a distance. So it's actually absolute value of -1, which is +1. Then I go to B, and I know it's 2 pi divided by something. And the something comes from the distance between your 2 points. So we need to figure out how many units are there between where we started and where we ended. So where did we start this one? About 0.5. And where did we end it? 3.5. So how many units are there between 0.5 and 3.5? 3. Okay, so the distance between points or from starting point to end point. C is always the trickiest one, and I don't know why. People always struggle with C. C is how much we've pushed it over. It's our horizontal translation. So normally these start at the y-axis, but we need to know how many units did I push it over to move it horizontally. So how many units between the y-axis to our starting point? How many units between our y-axis and our starting point? 0.5. So grabbing my red pen, on the graph, this is A. Either one, it doesn't matter. B is my blue line, or the distance between the 2 center points, and it's not really B. We know it's 2 pi divided by B. C is the little distance here that I've shoved it over, so it's the distance between the y-axis and our starting point. And D is the center line. D and A are usually easy. It's C and D people struggle with. So you just need to remember you're looking at the x values. B is the distance between. C is the distance from the y-axis to the first point. Last step, we just need to throw it into the equation. We need to start with y equals. You can't just start in with A. Do we have an A value? But it's 1. Do I need to write it? No. We have chosen this to be a sine graph, so I'm starting with sine. Excuse me, do I have a B value? It comes next. Do I need to open a bracket, and how do I know if I need to open a bracket? There's a C value, so I need to open a bracket. Next comes x or theta, whatever you prefer. Now to get 0.5, which means to the right, how do I put that into the equation? Minus 0.5, or minus a half if you like the fractions better. And at the very end is my center line, and it just is what it is, -3. It is what it is. Whew, there's our first sinusoidal equation. Now we got to do it again because it said a different sinusoidal equation. I'm going to go for the obvious, which is cos, which means I'm going to cut it from here to here. Does the amplitude change? Did I stretch this vertically just because I put those post-its on there? No. Does the period change? Did I stretch it horizontally just because I stuck 2 post-its down? No. Does the center line change? Did I move it up and down just because I stuck 2 post-its on there? No. What is the only value that's going to change? Is the C value. So if you look in the back of the book and everything is good to go, but your C value is off, that doesn't mean you're wrong. You just need to check what base graph they picked. Okay? Doesn't matter what base graph you pick, the A, B, and D will always be exactly the same values. I'm going to repeat that. The only thing that will change when the base graph changes is C. The only thing that's going to change when the base graph changes is C. So coast graph, I'm going to start at the first max and I'm going to end at the second max. And I'm going to highlight in a different color my coast graph. I could have chosen min to min. I just didn't feel like it. I chose to go from max to max. Well, A is the same, B is the same, D is the same. All I need to worry about is C. What's the definition of C? Distance from the y-axis to the starting point. How much did we just push this little guy over? So we have 1.25, so C would be 1.25. Are we all okay with that value? Let's write the new equation. So y equals, do we have an A value? Yes, but it's 1. Do we need to write it? Now I'm going to follow with cos because I've chosen to cut this as a cos graph. Do we have a B value? 2 pi on 3 hasn't changed. Do I need to open a bracket? What do I write next? Minus 3. Are those my only answers? No, I could have chosen to cut this anywhere and I could have done a negative sign, a negative cos. I could have continued this on and done something way down here. Why you would want to, I don't know, but you can choose to cut this anywhere. Okay? So again, when you look at the back, if your C value is off, it doesn't mean you're wrong. If your A, B, or D are off, you've probably made a mistake or the back of the book is wrong. Okay, let's do some more. Do you want to do the cos first or the sine first? Okay, what do we need to put in first before we can pick a sine graph? We need the center line because that's how we know where the points are going to stop. How do we find the center line? Okay. Again, you don't need to show the calculation. If you could do it in your head and you can just see it, great. I'm just showing you where we're coming from. So look at the max, 9. Look at the min, 3. 9 plus 3, divide by 2, 6. Again, you'll know if you're off when you draw it because it won't be symmetric. If you could just look at it and see it 6, great, draw the center line at 6. Okay, now we have lots of choices for cos, so let me show you all the options. I thought we were doing sine first. Yes, we are. Thank you. Okay, so there's one sine graph. We could cut it there and there. I could come over to the next time it hits the center line. What kind of graph is that? Negative sine. Well, I could just keep going, and I could use the second max and the second min. That's positive sine. I'm like, oh, no, I don't like that. Let's move it over here. And we have, it is completely your choice. It doesn't matter. They're all going to give you the right answer. I always say go for the obvious. Go from the first time it crosses the center line to the second time. Okay, why move it down if you don't have to? If it helps to highlight that so you can see it, then do that. Okay, A, B, C, and D. I like to start with D because it's the easiest for me. What is D? It's the center line. It's how far have we pushed this graph up or down. You can clearly see by the center line we've picked it up and we've plunked it 6 units up. Which one is related to D? A, so I like to go to that one next. What's the definition of the amplitude? Max or min to center line, so it's the height of the graph. How many units between the center line and the max, or the center line and the min, or the center line and the second max, or the center line and the third min? It doesn't matter. Any of them will be all the same height. What is the height of the graph? I kind of heard a mumble, but I didn't. Now I heard 3. We confirm that sounded like? Okay. Now we go to b, and we know it's not quite b, but it's 2 pi divided by something. 2 pi divided by what? Okay, how do we find the period on our graph? Starting point to end point. So distance horizontally from where we started to where we ended. 3. C is always the one that causes the most problems, and I don't know why. C is how much you've shoved the graph over. So have you pushed it side to side? So we're looking from the y-axis to the starting point. The starting point is on the y-axis. What does that mean? Yeah, we didn't move it side to side. We left it exactly where it was. So this means we stretched it vertically, we squished it in horizontally, and we moved it up 6 units. Look at the graph. Did we stretch it vertically? Sure, its amplitude is higher. Did we squish it in? Yes, because the normal graph just has 1 max and 1 min. Have we picked it up and moved it 6 units? There we go. Y equals. You talk faster than I can write. Now I'm good. I'm caught up. So do I need these brackets here? You can have them or you can not. We don't technically need them, but if you feel good putting them, put them. Show me how you're feeling on this so far. I'm getting it. I'm kind of getting it. Everyone needs to put it high. I can't see if it's right in front of you. Perfect. Okay, coast graph. Let me show you the options. Coast can go min to min. Coast can go max to max. I could go second min to second min. I could go second max to second max. I could go third min to fourth min. Which one do you want to use? So you want to go first max to second max? Again, if it helps to highlight it, highlight it. Yep, that's the roller coaster I would puke on. Have I told you my favorite ride at the X or like Valley Fair? So my favorite ride, it's very exciting. I don't know if most of you probably can't handle it. The bench. You know, nobody pukes on the bench. Nobody like loses shoes on the bench. You get to rifle through people's purses. The bench, I tell you, is the best ride ever. Okay, coast graph. Amplitude. 3. Period. Same thing. D value. Same thing. It's only the center or the C value that's going to change. How do we figure out the C value? It's the push. How much did you push it over? So y-axis to the first max, which if we look is, but you're pushing it away from the y. So you're pushing it along the x, but it's physically going from the y. Can we agree that it's 1? Okay, write me the coast equation. Okay, you tell me what to write. Do I need to start with y equals? Yes, because otherwise you're not writing an equation, you're just writing an expression. Whoa, why did that turn negative? What's going on there? Who got it? Show me your hand. Give me an air high five. Okay, isn't it negative cos? So who can explain why it's not? Because we've gone max to max. If we'd gone min to min, it would have been a negative cos. But we chose max to max. Are you ready to try one on your own? Read the directions carefully. Okay, you might have chosen to cut somewhere else and that's different. Your A, B, and D will be the same. It's just your C that's going to be different. Where would the majority like to choose to cut this? Here and? Oh, the thing's frozen. There at 2, I heard somebody say. And? Here at 27. Do we agree, or would we like to look at that again? Well, oh, I thought that was a 6. Never mind, it's an 8. It's all good. I thought it was a 6. Okay, so again, if it helps to highlight the actual graph, you can highlight it. We start with D. It's the easiest. You don't need to do calculations or show it if you can do it in your head, if you can see it. What's our D value? Confirm? Okay. I like to do A next because it's linked to D. Ooh, I heard 3.5. I heard 2, 3. Confirmed. Okay. Then I like to go to B. Offer of 2 pi divided by 25. Okay, can we reduce? Nope. C value? Okay, 2 if you cut at the same spot as me. If you cut somewhere else, it might be different. Tell me the equation. I liked when it was in stereo. And then do I need to put anything here? Who had it? Awesome. That's actually a really good stopping point because the bell's going to go fairly soon. So when you come back this afternoon, it'll just be a work period.